overcome temptations. Help us to be pure in thought, word, and deed. Bless all our faculty members and our parents. We ask all these in the name of our Lord Jesus Christ. Amen.
Once again, good morning to one and all present here. A special good morning to Mr. Sheikh Majid sir, and who is going to handle today's session. The topic of today's session is gate syllabus, okay, on electromagnetics. On behalf of Francis Xavier Engineering College, on behalf of Department of Electronics and Communication Engineering, and my own behalf, I welcome Majid sir to host the session. Sir. I welcome you, sir.
Thank you.
Over to Mr. Sheikh Majid sir.
Sorry. Good morning, everyone. So it's my great pleasure to talk to you people and share my knowledge on electromagnetics. Before that, I wish to thank the management of Francis Xavier for giving this wonderful opportunity. So let us start this session. We have less time, so we have to deal so many things. So directly I go to the topic. Right. So if you have any doubt, you can ask me immediately, or you can contact me also. I have given everything, my contact details. So let us start. Right. The subject I'm going to deal in today's class is electromagnetics. Even though the subject they have given simply one topic, it is a combination of three different subjects. One is electromagnetics, second one is TLW, and the third one is antenna. These three subjects are combined and they made a single subject in GATE. So it is the vast syllabus in the GATE exam. So we can expect more questions from this area. So if you are strong enough in this area, you can score 10 to 15 marks. So that will improve your GATE score in a huge way, right? So let us start. So today's session, what I'm going to cover is the mathematical tools required to understand electromagnetics, electrostatics and magnetostatics in a crisp way, and Maxwell's equations and wave equations, right? So you see all these things you have studied in fourth semester EMF theory, right? So these things I have to cover within 3 hours. So I give the concept, remaining things you know the derivation and all. And the problem with many students I face is what is the meaning of the equation? Many students don't know. We need to know that only, because in GATE they ask only mathematical problems, so they don't ask any definition and all. So we must know the meaning. If we know the meaning, we can solve any problem they ask. So I give importance to understanding the equation and the meaning of the concept, right? Okay, so first we start with the mathematical tools. As an engineer, the language of engineers is mathematics. So without knowing the basic mathematics, that is vector calculus, it is very difficult for us to understand electromagnetics, TLW, and antenna. So vector calculus plays a huge role in these three subjects. So first I deal this. Don't worry, I won't derive the equations and all, but I will give the meaning of the equation. That is very important. In GATE, they ask that only, whether you understand the meaning, understand the concept, right? So let us start. So first, mathematical tools required to understand electromagnetics. Okay, this tool is useful when you study engineering mathematics also. There also we have vector calculus. Whatever there, it will be useful for solving the problems. So so first the subject is electromagnetic field. So we must know what is field, right? We have heard the term field in our real life, educational field, sports field and all. What we feel in the educational field, there we feel education. In sports field, we feel sports, some games. So like that, in electromagnetics field, we have to feel something. What is the things we feel here is electric field and magnetic field, right? So that only we are going to study in the subject. Where we feel the field in space, right? Sports happening in one particular space, that is called ground or stadium. education happening in one particular space called school, colleges, universities. Like that, electromagnetic field occurs in what you call in the three-dimensional space which is surrounding us, right? So we know two field in our real life. One is scalar field, and another one is vector field. In sports field, we associate sports. In education field, we associate education. Whereas in scalar field, we associate every scalar quantity to field. In vector field, we associate every vector quantity into field. Right? So that's what we have to know about field. Next. Right? So as I told, field is something we feel in the space. In electromagnetics, we are going to feel electric field and magnetic field in the space. So that is the thing we are going to see. So let me go fast. These are all basic. We don't spend so much time on this. So first here you see, this is a best example for what you call scalar field, right? So here you see, this is a space. Here we associate a scalar, that is a temperature is a scalar quantity. We associate a scalar to a particular point. So this is the best example for scalar field. Similarly, vector field, we associate a vector at a particular point. So field is felt in the space. So here you see, here we associate a vector. 77 is a number. This number is in this direction. That is, this is talking about a wind blow, right? The wind velocity is 77 and the wind is blowing in this direction. So it has both magnitude and direction. So it is a vector field. So here you see, this is the magnitude, this is the direction. So here we feel vector, right? So this is one general example. But in our subject, what we are going to see, we are going to feel electric field and magnetic field. So electric field, we know it is vector quantity. That means in a three-dimensional space, we are going to associate one vector quantity called electric field at every point. So that's why it is called electric field. We will see what is electric field and magnetic field soon. Right? So those things I will, what is the definition and the meaning of electrostatics, I kept it in the second session. Here we see the fundamentals. So I give importance to fundamental mathematical concepts. The first thing we must know in the electromagnetics is del operator. This is very, very important operator. Because you must have remembered you studied only del in all 5 units. So we must understand what is del. Del is a vector differential operator, right? So detailed things I have put it in my channel, but I give very, very important points. So those things only I will explain. So the definition for del is equal to I is a unit vector, dou by dou x, j dou by dou y, and k dou by dou z. And another thing we have to remember is what is the unit of del, right? So here xyz is a coordinate. We know xyz is in length. Length is having a unit of meter. So this is 1 by meter. Dou by x is below. It is in the denominator, so it is 1 by meter. So the unit of del must be a 1 by meter. So the unit of del is 1 by meter because based on this they have asked one question in GATE exam. So that's why this is very important. Okay. Next. So del alone cannot do anything. What del will do is it will act on either scalar or vector field and it will create a new field. What it will do, let us see. The best example for vector field is electric field. We know electric field is a vector. Magnetic field is a vector. Scalar field is potential. Potential is a scalar, right? So they'll operate on these fellows and create new field. In what way it will create new field? Let us see. This is another important question which you can expect in a GATE exam. You see here del operate on scalar. V is a scalar quantity, right? Del operates on a scalar which results in the gradient, right? So, but gradient is a vector. How it has become a vector, that and all I will explain later. So del acts on a scalar and it produces some vector E means, then it is called a gradient. Right? So del V, how can you pronounce? It is gradient of V. Next, del acts on the vector. Del acts on the V is a vector. del acts on the vector and it results in some scalar. Del acts on the vector and it results in some scalar like k. Then this is called divergence. So here you see this, you have to pronounce divergence of B. Don't say del dot B. If you say del dot B, we don't understand the concept. Hereafter, try to say divergence of V. Then you will understand so many things. Like the del V, don't pronounce hereafter. Gradient of V, like that you pronounce. Then here you see del operates on a vector and results in another vector. Del vector, the acts on a vector and produces another vector. That operation is called curl. Then del, it is a double del, so del squared, second order del, that acts on a scalar, that operation is known as Laplacian. Surely this type of question you can expect in the maxi following not correct answer. Like that question you can expect. It acts on the scalar or vector. So this is the way del acts on the scalar or vector. So how it happens, let me explain everything. So the first thing is gradient, right? So gradient is the first important point we have to know, right? So gradient or what is the meaning of gradient is gradient gives maximum change. How one scalar parameter changes maximum in a particular direction, it is given by gradient, right? So gradient gives maximum change or gradient gives maximum slope. These 2 points are very important because in order to solve many gate problems, this point is playing very crucial role. So del is a maximum change or slope. Here you see del operates on the scalar and results in a vector. This is what gradient, just now only I told. So what is the thing? How scalar can become a vector? See, temperature, we know temperature is a scalar. Temperature change is a gradient. Fine. So what's the meaning? You see, we are entering our home, right? This is our hall, let us assume, and this is our kitchen, and this is our bedroom. Fine. So with the AC. So when you enter here, if I ask you to go to the maximum change in temperature means from compared to hall, where you will go to the kitchen because kitchen has more temperature compared to the hall. So here temperature is a scalar. When you go in this direction, the temperature changes towards maximum in positive direction. So this will become temperature gradient. So temperature scalar, change in temperature becomes temperature gradient. Suppose if I ask you to go in the direction of least change of negative maximum change means you are in which direction you will go? You will go in this direction because compared to the hall, bedroom with the AC has very least temperature because AC is running. So this is negative gradient because you are going towards the direction of maximum change. There may be some other hall which is closer to the which has the temperature closer to this hall temperature. So if you go towards kitchen, you are going towards the direction of maximum change in temperature. If you go towards the bedroom with the AC, you are going towards the direction of least temperature. Both are positive maximum, it is negative maximum. So this is talking about gradient. So gradient equation, you know, for 2 dimension, del is equal to I into dou by dou x plus j into dou by dou y. For 3 dimension, del is equal to I into dou by dou x, j into dou by dou y plus k. This is a unit vector, right? So whatever the things in block letters is a vector quantity. So k in block means it is k unit vector, right? So gradient gives vector quantity. So gradient of del operator operates on the scalar and it will result in a vector. And second point about gradient is gradient gives maximum change of any parameter, any scalar parameter. So these things you must remember. That's enough for gate exam. So what are the things? Del T means gradient of T. T is a temperature means it is a temperature gradient. So temperature gradient converts a scalar field into a vector field. So we know del T is a vector. So del T is a vector, please understand. T is a scalar, del T is a vector. So vector has both magnitude and direction. So direction of del T indicates direction in which maximum change occurs. I told already, right? What is the magnitude of that maximum? That is given by magnitude of del T. So magnitude of gradient. So that's all about gradient. These 3 points only you remember. It is enough to solve any problem related to gradient. So here we have solved one problem. F of xy is equal to 5y minus x cube y square. Right? It is a two-dimensional gradient. Del fxy. Why it is called a two-dimension? Because it is belonging to, it has only two coordinates, x and y. So we can say it is a two-dimensional gradient. So del fxy is equal to, I told what is the formula? Here you see, del is equal to this one, del fxy is equal to dou f by dou xi, dou f by dou y j. So here dou f, dou by dou x f I, dou by dou y f j. So if you take a partial differentiation, 5y if you differentiate it will become 0, xi if you differentiate this minus 3x squared, y squared I, this y you differentiate with, this factor you differentiate with respect to y, 5y if you differentiate it will become 5 x cube, y squared if you differentiate it will become 2yj. See, the question is scalar quantity. It has no unit vector, it is not a vector. Whereas this is a vector, here you see it has unit vector. So f is a scalar, del operates on the vector, sorry, scalar f results in the vector. So f is scalar means del f is a vector. T scalar means del t is a vector. So del f means gradient of s. Right? Please remember that. And another thing they ask is find gradient at 1, 2, 3. That means at point 1, 2, 3. X is equal to 1, y is equal to 2, z is equal to 3. So here you substitute x is equal to 1 square, 2 square, and here you see x is equal to 1 cube, y is equal to 2. So like that you have to find it. So another thing you must remember in electromagnetics is all the parameters that we deal in the EMF are found at particular point. That is very, very important. All parameters are obtained at a particular point. Why? I told it is talking about a field. Field means associating some parameter that we study in our subject to particular point in a space. So everything we find at particular point. So in exam surely they will ask to find the gradient at particular point like this. Hope you have studied in mathematics and EMF also. They ask the question, find the curl at this point, -1, +2, -3. Like that they should have given. Because these parameters, factors can be obtained at particular point in the space. These are all called field quantities, right? So let us see all the things. Okay. So now we studied gradient. Now we have to understand fundamental theorem of gradient. This is called the fundamental theorem of gradient. This is very, very important theorem. Fine. Here you see this goes from A to B, integral A to B, del T dl, Tb minus Ta. What it is indicating, first thing you are understanding from this equation is, here it varies from A to B, the integral. It is a line integral. dl is, it is dl, right? dl vector, please remember dl vector, it is a line integral. This line integral goes from, let us assume, it is a line, this line integral goes from A to B. Right? So point A to point B. What is in the right hand side is telling, don't do this line integral. Instead of doing this line integral, what you have to do is find the value of this t at particular point B, that is n point. T at B, subtract t at A. That's what. So instead of taking this much line integral from A to B, what you have to do is you take the endpoints value and subtract destination source from the destination point. So that is what this theorem states. This theorem is applicable only we have del t, right? Because this is talking about maximum. Del t is talking about maximum change, I told. Maximum change in temperature. So this is very, very important point. So if this fundamental theorem of gradient relates line and its end, we know the end of any line is a point. So what is the end? This is one point. This line has two ends. One end has one point, another end is one point. So the end of line is a point. So gradient theorem relates line and its end. So and its end, which is nothing but point. 2 points. We can say it is 2 points. It is line integral. Don't do line integral. Instead, find the value at a particular point. This is what gradient theorem. This you must understand. By knowing this only, you can understand Stokes theorem and divergence theorem. That's why I'm giving importance to this theorem. Line and its end. So here you see, this is applicable only when we have del t. Suppose if the equation has t dot dl a to b, it is not applicable. Why it is not applicable? Let us see with one example. See, del t is maximum change. Here you see, right? So this is slope I told. Slope del is slope or del t maximum change or slope. So suppose let us assume this is 0 meter. This is 100 meter. How can I calculate the height? First, what I do, what is the height at this point? I find 100 meter. Then I find what is the height at this point, 0. So I find 100 minus 0. That is what this one. Here, TB minus TA. Difference between the two endpoints. Like that also I can find. Otherwise, I can, how can I find from here to here 10 meter, from here to here 20 meter, 30 meter, 40 meter, 50 meter, 100 meter. So this is a line integral. This is what our A to B del T dot dl, right? So del T, I told gradient gives maximum change, right? If you go in this way only, it is giving maximum change. Suppose if you go like this, it is not a maximum change. Only if you go it is this way, it is a maximum change. It is not a maximum change. So this is the first point you have to remember. So gradient theorem relates line and its endpoints, and it is independent of the path. You see, integral is independent of path. I can find only endpoints on, right? Okay. Next we come to the divergence, right? So divergence is nothing but, as the name itself is telling, spread. Diverge means spread. So it is talking about spreading a vector, right? So how vector is spreading from the particular area, that is given by divergence. Here you see the source is inside, this smoke is coming out, it is spreading, so it is divergence, right? So net outward flux of a vector A through a surface bounding a volume indicates the presence of source, right? This statement you should have studied in EMF. That's what this one. You see, net outward flux of a vector A. Let us assume flux is a flow. This is a vector A. This smoke is a vector A. Net outward flux of a vector A through a surface. It is blowing out of the surface. That is the mouth of this chimney. Through a surface bounding a volume. What is the volume? This chimney is a volume, right? So this volume is bounded by the surface called open surface. Through that smoke is going. That smoke flow is known as flux. Flux is nothing but a flow of something, right? So if there is some flux going outside means there is no smoke without fire. So the source must be inside. Even though we don't see it, it indicates if the flux flows out, there is a source inside. This is what the fundamental behind Gauss law. Right? When I deal Gauss law, you must remember this point. Then only you can understand Gauss law very easily. Fine? Okay. So this is a divergence equation. Divergence of F. I told divergence if del operates on the vector. So here vector is F. Divergence of F is nothing but del dot F. So if you remember, forget, you just remember dot means divergence. Take del dot, dot means divergence. cross. Del cross means it is curl. So divergence of f is nothing but del dot f. You know how to take a dot product from vector analysis. Use that and find the answer. So since it is a dot product, we know the result of dot product is scalar. So divergence is a scalar. So del dot f is a scalar quantity. Please remember that. Right? Why it is a scalar? That is the reason. Okay. Now divergence has three meanings. If divergence is positive, if divergence is negative, if divergence is zero. Divergence is positive means it is spreading out. Right? So that's what we study in our static charge. Hope you have drawn the diagram like this for positive charge. Here you see the electric field spread. So electric field diverge. So it is called positive divergence because it is spreading from the source. So here you see P is a source, the electric field spread. That's what positive divergence. Right? Divergence of a vector is positive here. Then you must remember for negative charge, you have drawn electric field like this. Here you see everything towards there is a source. This is very, very important. That electric charge is present. Means positive is present. Right? So that is the meaning. If suppose if they give the in the gas signal, so all the fields go towards that. It is acting as a sink. This sphere is acting as a sink. If there is divergence is zero means it is not spreading. So it neither spreads nor converge. So it will simply flow. Right? So spreading means from one point only we can spread. Right? Similarly, converging means a negative divergence towards one point only it will go. Right? Divergence zero means it will simply flow like a river. So if divergence zero, there is no source to emit, no source to collect. So it will simply flow. The vector will flow. So next one, the example divergence of f is equal to del dot f. We know. So they give vector f. We know how to find divergence. This and that is studied. I don't want to waste my time. Just example. The tough example I will give later. Right? So divergence of f is equal to del dot f. So take del f. What you get is this one. What I want to emphasize here is you see the question as vector. Del acts on the vector. You see the result as scalar. So if they give objective type questions with this is a question and answer in the vector and only this is a scalar, no need to do the problem. Directly you can write the answer. So it's a shortcut. For that only I emphasize this one, right? So del operates on the vector and take a dot product means the result will always be a scalar. So from option A, B, C, D, if they give everything as vector, del dot f they ask you to find, and this is a scalar they give means no need to do the answer. You remove everything. This is a direct answer. You write it immediately and save your time. And you see what is the divergence of vector field XAX, YAY, ZAS. This question was asked in GATE 2013. So this is a very simple problem. Del dot A is equal to what do you call dou by dou x, right, into x plus dou by dou y plus dou by dou z, right, if you take a dot product. Because del means you know dou by dou x ax plus dou by dou y plus dou by dou z az. Right, if you take a dot product between dou x and ax, ax dot ax is 1. So it is dou by dou x, like similarly dou by y. So 1 plus 1 plus 1, dou x by dou x1, dou y by dou y1, dou y by dou z1. So the answer is 3. Option D is the right answer. Fine. So this is the next question they have asked in GATE 2007 exam. In the same manner you can do and you get this is the answer, right? So if time permits, we will come and do that problem. Otherwise, you try or ask me in the chat. Okay. So next thing we have to remember is curl, right? Curl means we know curly hair. Curl means what? It is a rotating. So curl indicates rotation of a vector, right? Divergence means spreading of a vector. Curl of a vector indicates it is a rotation of the vector field. So we know curl turns vector into another vector. We know del operates on the vector and it will result in another vector. So del operates on the vector. I told for curl cross product CC, you remember del cross A is equal to B. So like that. So vector has both magnitude and direction. So curl has both magnitude and direction. The magnitude of curl indicates what is the circulation, how much speed it will rotate. That was given by magnitude of the curl, whereas direction of the curl indicates in which direction it is rotating, whether it is rotating in anti-clockwise direction or rotates in the clockwise direction. That is given by direction of the curl. So here you see this is curl. This vector is rotating around the point P, so this is curl. Here this vector is not rotating around the point P, so here curl is 0. Here divergence is also 0 because what is the reason? It is not converging towards this point or it is not spreading towards this point. So here divergence is also 0, curl is also 0. So curl at point P is not equal to 0 here. Here curl at point P is 0. Here divergence at point P is also 0. Here divergence is 0 because this at point P, because the vector is not diverging, it is rotating. So here divergence of vector is 0, right? So you know what is the formula to find a curl of a vector? This is given here, right? So this formula you have studied, so use that, right? So this is one example I have given. So how can we do? We can say that this is del cross F ijk dou by dou x dou by dou z. So this is a curl. So just a matrix multiplication. Once you take matrix multiplication, you will get this answer. So this is the answer. You see in question we have vector, right? And in answer also we have vector, right? So curl turns vector into another vector. Fine. So that is the important point we must remember about curl. So here also we can understand if they ask del cross F and in the option they given A, B, C, D, it is scalar, scalar, vector, scalar. You don't need to find the answer using all the mathematics. Just see the answer, neglect it, neglect it. Just you take this as an answer. No need to do the problem, right? So this is the way we can find the curl of a vector. Right? Hope you know how to find this. But in exam, please remember they won't ask you to perform all this mathematics. There must be some twist in the answer. So whenever you see the question, you see the answer also. Then only if you are not able to find the answer, then you do mathematics. Otherwise, try to get the answer from the options. In that way, only 99% they will give the questions. Right? Right? So now we understand divergence, curl, and gradient. This question you see, if E is the electric intensity, what is del cross E? So if you do in mathematics, it is a 6-mark question in M2. But here we should not take that much time. How can we find it? Is very simply del cross E is nothing but what I told del. This is a vector, right? So it is del cross E means it is curl of E, like that you remember. That's why I told. Del this one means it is a grade. right? So gradient means maximum change. Curl means rotation. In rotation, can you find where is the maximum change? You cannot find. In divergence only, we can. If you go like this, whether you are going in the maximum direction, you are going in the minimum direction, you can see. But if you rotate like this, you cannot change. You cannot tell whether you are going in the maximum direction or minimum direction. So the answer must be 0. Gradient of curl of E. Curl of E is rotation. Maximum change of rotation is nothing but 0 because we cannot find a maximum change in rotation. So the option D is the right answer. Like that you have to switch. So that's why I told don't say del cross E, you say curl of E or rotation of E, divergence of E, spreading of E, change of E, like that you talk. Then only you can solve the problem in the simplest manner. Okay. Here you see, find the curl of this one, 2xi plus 3yj plus 4zk at p1, 2, 3, right? So you know how to find. What you do? You do all the mathematics, ax, ay, az, and all, right? I told there is one shortcut to find the answer for this. You see, we have to find the curl of A. That is rotation of A. But you see the vector. This vector is given as A is equal to 2xi plus 3yj plus 4zk, right? So here you see the component, this is a unit vector and the component is 2x. This is a unit vector, the component of vector is 3y in j direction. In k direction, the component of vector is 4z. Here you see vector is along I direction. Let us assume this is ijk. This is jk. No problem. Otherwise ijk. You see, I take only 2 dimension, I explain, then you can go for 3 dimension, ij. Here you see the vector is I, unit vector is I, this is I direction, unit vector is j direction, and the vector component is changing in the x direction. X is nothing but equal to I direction. So direction of the vector is I, and the component is also along I. Here direction of vector is j, component is along, sorry, the component is also along j, right? So this is one. Similarly, if it is z, k, the vector direction is k, the component is also along what you call k. So if both are along the same direction, vector and the component along the same direction, it has only divergence, right? So, but curl is 0. Please remember. Suppose if they give 2yi plus 3xj, right? Find the divergence of this vector. This is a vector, yeah. Find the divergence means here you see vector I, vector j. Here vector direction is I, component is along j direction. Here the vector is j, but component where is along x, that is I direction. Here you see this only will give rotation, but this will give spread only, right? So whenever you see the question like this, if vector and component are along the same direction, it has only divergence, right? If vector and component along the are orthogonal, perpendicular, it is I means x, y means j. So both are perpendicular to each other. If vector and the component are perpendicular to each other, you take that is curl only. It doesn't have divergence, right? So simply I can say, you see, this is a vector, this is a vector. Here you see, here you see, here you see. If you keep some object here, if you apply the force like this, it will go like in this direction only. It won't rotate, right? So curl is 0, right? Why curl is 0? Because you see the vector is along the let us assume this x direction. The vector is along the x direction. The change is also along the x direction. Here you see maximum. Here is also minimum. Then it is minimum like this. Vector is x direction. The change is also along the x direction. When your equation is like this, it won't rotate. It will diverge. So that's what I told this one. 2xi plus 3yj plus 4zk. Vector change. This is vector. This is change. Right? So vector and component along the same direction, it has only divergence. Suppose you see this is like this. If you keep some object here, it will rotate. Here you are giving maximum force, here you are giving minimum force. So it will rotate. Here you see vector is along in this direction. You see all the vectors are pointing towards x direction. But change is in y direction because here it has minimum, somewhat maximum, both are perpendicular. Vector and a component are perpendicular to each other. So it has curl. So here vector, this is I, component is x, that is j. So both are perpendicular, right? So what is happening? So it has only curl. Clear? Sorry, it is I, it is x. I means I. So both are in the same direction. This I direction, x means also I direction. Vector and the component are in the same direction. This is j. Y means also j direction. Both are in the same direction. It has only divergence. So curl is 0. No need to solve the problem. Directly put 0 as the answer. In the options, if you have 0 or 1 as the option, try to find that may be the answer. Mostly, if they give 0 or 1 in the options as an answer, that two may, one of that two may be 90%, it will be an answer, right? So like that only they will ask questions. Next you see, this is a wonderful question asked in our TRB exam, the divergence of the curl of a vector. So if they ask like this, you see divergence of the curl of the vector. First curl of the vector, let us assume vector A. What is the curl of the vector? Del cross A. Del operates on the vector, cross product will give curl. What is the divergence of, this will introduce some vector because the curl of a vector is a vector. Divergence of this vector is del dot B. So divergence of a curl of a vector is 0. Why? You see curl means rotation. Divergence of curl of some vector A. This is a vector A, this is rotating. Curl of A means rotation of A. Whether this will diverge, something which is rotating will spread, it never spread. So the answer is 0. So in mathematics, how can you write? Divergence, del dot means divergence. Divergence of curl of vector. Del dot del cross A. That is equal to 0. That is the meaning of this statement. So this is curl of A. This is divergence of curl of A. Dot means divergence, cross means curl. Right? So rotating vector will not spread. That is the statement. That we know. Something which rotate will not spread. So option A is a right answer, right? Okay. Now we come to the Stokes theorem. Before we remember Stokes theorem, we must know this one, delta D dl is equal to TB minus TA, A to B. Line, point, right? So this is what gradient theorem. Now we come to the Stokes theorem. You see, gradient theorem relates line and its end. End of the line is 2 points. Similarly, Stokes theorem relates, you see, surface. ds is a vector. It relates surface and you see the integral is closed. This is very, very important. This question they have asked in one GATE exam. So this understand. This closed integral is very, very important. Why this closing is very, very important? I will tell you. This is line. You see the relation. The end of the line is point. The end of the surface is line. You see, this is a surface. Let us assume this is a tiles in our home. This is a surface. What is the end? End is this boundary only end. End of the surface is. So it relates surface and its end. Right? So only it is a surface, open surface, then only we can use. So here surface is open, line should be closed. That is contour. Very, very important. Because the end of the surface is close to boundary, close to line. So This closing is very, very important. This question they have asked one time. So Stokes theorem relates surface and closed line or curve. This is very important. Next, you see the statement is very simple, but statement is not required in any exam, in competitive exam. Anyway, I write it. The surface integral of the curve. You see surface integral of the curl del cross A of a vector field. This is vector field over an open surface. You see, open surface is equal to the closed line integral. You see, this is closed line integral of the vector A along the contour bounding the surface. This closed surface, sorry, this closed contour should have bounded this surface. Right? The statement is not important. It is important for your university exam, but for just understand this. So here we must know, we have studied in our school days, surface is a scalar, but in our subject surface is a vector. So ds, right? ds, any vector can be written in terms of its unit vector and scalar. So ds I can write as ds into n cap. Surface is a vector. So how this n cap will be there, that is a question. If it is a closed surface like that, at this point n cap will be like this. That's what del s they have written. At this point it will go like this. It is all perpendicular to this surface normal. This is what n cap. This is very important. This we use widely in our magnetic field. So whatever the topics I am telling here, which will be widely used in the further course. So please understand these concepts very clearly. Other things you can study on your own. So this is n cap here. If it is lying here, it is n cap. This is for closed surface. This volume, this is a volume. Volume is nothing but a closed surface. Here n cap will be like this. Top side it will go like this. Bottom side it will come like this. Like that it will go at every. It is an open surface. Both sides open. For this side it will go like this. For bottom side it will come like this. That is the only two options, right? If your surface, let us assume this is our tile. Tile means where is your unit normal will be. It is always looking at your ceiling. That is the point. Just remember this concept we will use. So please remember this. This is what n cap, right? For open surface there is only two options. One will go top of the surface, other will go bottom of the surface. Otherwise, where is another normal in your tiles? It will go towards the ground. This is what n cap. Compared to this, it is opposite, so minus. Right? Okay. So here you see Stokes theorem. I told Stokes theorem relates surface and closed line. First, you must remember this. Right? How it relates surface and closed line, I don't derive. I just give the concept. Let us assume the area of this tile is 1 by 1, this tile is 1 by 1, this tile is 1 by 1, this tile is 1 by 1. What is the total area? 4. Because this is 1, this is 1, 2, this is 1, 2. So it is square, so 2 by 2 is 4. That is what this one, right? So what is that? Suppose if it is a vector A dot dl. You see it is a displacement length. So this length I add all this integral, right? Line integral. So I add all from, I start from here and go here and go here and go here and go here and come back again. Fine. So I come back here. So this is what my closed starting and end point are same. That's what it is closed. This is what my A start and end. What about this? This is del cross A. You may have doubt whether it is del dot or del cross. So at that time you have to use this. So I can find the answer for this question in a different way also. How? The area is 4. Otherwise I can say what is this area? This area is this one, 1 by 1, 1. This closed area, 1 by 1, 1. This closed area, 1 by 1, 1. This closed area, 1 by 1, 1. If I add all the closed area, 1 plus 1 is 2, 3, 4. That's what. You see here I rotated. When I rotate, this 2 will be cancelled, I get this area. When I rotated here, this 2 will be cancelled, I get this area. When I rotated, this will be cancelled, I get this area. So all area I will get. So Stokes theorem is talking about curl of vector. Please remember. That's why. When you have doubt, please remember this example. You don't put a del dot. It is del cross A dot ds vector. Just now only I told, right? Right hand side A dot dl, it must be closed. Surface and its boundary. That's what surface and its boundary. Stokes theorem. Fine. Okay. Next divergence theorem, in the same manner, it is volume and closed surface. Please remember this must be closed vector. Volume is a scalar, right? So it is a divergence theorem. Divergence theorem relates volume and its end, that is called the surface. Detailed analysis and a lot of examples I have given in my channel, you can see in that, right? Majid lectures. So we have studied three theorems. That's what important about this. What is that? Line and its end, that is nothing but point, that is gradient theorem. Surface and its end, that is closed line or curve, that is Stokes theorem. Volume and its end, that is closed surface, right? That is called divergence theorem, right? So it is called del dot A. Why it is del dot A? I have given an example, so I don't want to waste time on examples. We have to solve problems, so you can see it in my channel. Del dot A dv is equal to closed integral A dot ds, right? So these are all things we must remember. Before that, right, some more problems are there. Okay, you can see that these examples, Gauss divergence theorem relates. You see, just now only I told divergence theorem relates line integral and points. No. Volume and surface. Volume and surface, okay, but I told it is closed surface, so look for that answer also. Volume and closed surface. So this is not a right answer. This is a correct answer. Who relates line and its point? It is gradient theorem. Who relates surface and line? It is Stokes theorem. Right? Okay. Now you see, relate this. This is a great exam question. Relate the volume integral into surface integral, which is nothing but our divergence theorem. Del dot A means, del dot A dv means it is closed surface A dot ds. Fine. So please remember, it is closed, it must be surface. Suppose if they give C A dot ds means it is closed line, not a surface. So this is wrong answer. This is the right answer. It is surface or double integral. Otherwise, it must be double integral A dot ds. It is C A dot ds closed means it is single integral A dot ds. Right? You understand the difference? That is very important. Next, you see, sum of all the sources of the field in a region will give. If you sum all the sources in the region, source means it will spread. I told sink means it will collect. So source means it will spread means it will go out. So sink only it will spread. So inside means it is sink. So this is wrong answer, right? Rotation, no. Source means it will spread only. There is no rotation. Here the word rotation is there, so it is wrong answer. Here also rotation is there, it is also wrong answer. So source means it will go out, so net outflow of the region. So like that you have to think. Fine? Okay. Next one. If the function is solenoidal, divergence theorem gives. So first we must know what is solenoidal and irrotational. We know del dot A is divergence. If divergence is 0, that is del dot A is equal to 0, it is solenoidal. This question they have asked in GATE exam. Please note it down. That is divergence of vector is 0 means that vector is called solenoidal vector. Curl del cross A is curl, we know. If curl is 0 means no curl. Curl means rotation. If curl is 0 means it is irrotation. That's why it is called curl 0 means it is irrotational. What is the question? If divergence is solenoidal, what is the output of divergence theorem? What is divergence theorem? Del dot A dv. That is volume integral. This is closed surface A dot ds. Here you see the function is solenoidal. Solenoidal means what? Delta D is equal to 0. Left hand side is 0 means right hand side is also 0 as per the divergence theorem. So answer is 0. That's very important. So once you know the meaning of this, you can solve the problem. Next, the divergence theorem value for the vector function. Here they ask what is the divergence theorem value. So if you solve by using mathematics, it is a 16-mark question because you have to prove left hand side and volume integral, right hand side you see. But I told one shortcut, you see here vector is in I direction, the component is in j direction. Here vector is in j direction, the component is in k direction. It means k. Here vector is in k direction, the component is in I direction. That is vector and component are orthogonal. If vector and component are orthogonal, divergence is 0, I told already. It has only curl. So as per the divergence theorem, del dot f, here they have given vector f. So del dot f dv, that is equal to closed integral f dot ds. This is what divergence theorem. You see, as per the statement, delta df will become 0. So 0 is equal to 0 only. So option B is the right answer. You don't need to do like a 16-mark question. You have to solve the problems like this only. Then only you can save your time. So concepts are very important. Here we don't use any mathematics. Just knowing the concept, we solve 16 mark in within a second. Okay. Here you see this is a wonderful question asked somewhere. I think it is TRB question in our Tamil Nadu. Here they have given delta f is equal to 3 and asked us to find surface integral of f dot n ds. So it is surface integral. Who is relating surface integral del f dot n ds? Right? So you see what they ask is this answer. This only we have to find. What is this? See, if you use a formula, you never find. But we know, as per the divergence theorem, we know del dot f dot n ds is equal to del dot f dv, volume integral. Right? So this is what I have to find. Instead of finding this, I have del dot f. So it is nothing but divergence theorem. So del dot f, we know it is volume integral 3 dv. So 3 is a constant. Take it outside. 3 dvv. What is the surface area they give? Surface of a sphere. So dv means it is a volume of the sphere. So 3 into of the sphere is 4 by 3. It is talking about unit sphere. So r is equal to 1. So 3 cancel 4 pi into 1 cube, that is equal to 4 pi. Right? So in this way we have to solve the problem. Right? This is the shortcut. If you apply all the things, it will take minimum 30 to 40 minutes to find the answer. Okay. Right, and this is one more question asked in gate. If time permits, I will solve. Otherwise, you solve and tell me the answer. I will clarify it. Fine. And here you see one more simple question. Here, what is the value of closed integral dl of a circle of radius 2? R is equal to 2. See, it is a closed integral dl. That means it is a closed surface. It is a circle, right? And they are talking about what is the total length for this closed circle, right? So here you see this is closed surface. DL means what is the total circumference? It is what nothing but this DL is talking about the shape which is called a circle. So closed circle, what is the total circumference? Because total means DL closed means it is a closed surface. So total closed in the circle is 2 pi r. What is radius here? It is 2. So 2 pi into 2, that is equal to 4 pi. So answer is option C. Clear? You understand the meaning? So closed integral dl means total length closed starting to end point. So that is equal to 2 pi into 2, 4 pi. Simple answer. Right? So that's all about this mathematical requirements. I hope you understand everything, right? If you have any queries, you can ask anytime. Any questions? Okay. I go to the next topic, electrostatics and magnetostatics. Shall I take some water, please? Now we enter electrostatics and magnetostatics. This is what our subject, right? So in that, what we have to study is what is electrostatics. Okay. I'll erase it and write it properly. Electrostatics. Right hand side, we can go for magnetostatics. I simplify it and tell everything in the shortest way. So first, what is electrostatics? Electrostatics means study of static charge. Right? What will happen when the charge at rest? If you study that, that is called electrostatic. Magnetostatic means study of moving charge. What are the things happens when the charge moves? Moving charge means moving charge creates current. So what are all the things happening when current flows through any conductor or anywhere? That study is called magnetostatics. Right? So hereafter, whenever you say current flowing through a wire means you are talking about magnetostatics. Study of charge at rest is called electrostatics. Right? So electrostatic deal with the electric field, right? The source of electric field is static charge. E is electric field, it is a vector. The source of electric field is static charge. Magnetostatics deal with the magnetic field. The source of magnetic field is current element. Very, very important. It is current element. Or you can say it is a moving charge. Sorry. It is a moving charge creates magnetic field. Static charge creates electric field. Fine. So that is a very, very important point. In electrostatics, we have important two laws. One is Coulomb's law. Second one is Gauss law. In magnetostatics, we have two important laws. One is what you call Biot-Savart law, and the second one is Ampere circuit law. Right? So this is very, very important. Here we are going to fully study about electrostatic field. So it is electrostatic field. E field is diverging field. Hope you remember divergence and curl. H field is rotating field. Rotation means curl. That's why we studied about divergence and curl. So electrostatic means you must remember del cross E and del dot B. Del cross E is equal to 0 and del cross E is equal to 0, del dot D. Hmm. Erase it. Del dot fine. I will explain everything. Delta D, that's what Gauss law, right? This is called divergence, and we know another thing, E is equal to minus del D, gradient. All the three mathematics I have explained, right? Here in statics, del cross H is equal to J, del dot G is equal to 0. You see curl, you see divergence, H is equal to minus del Vm gradient. Only these three equations, these three mathematical parameters are playing crucial role in total subject. Right? Let us see all the things now. So I make electrostatics in only one slide. This will be helpful for your exam. Right? So I told in electrostatics we are going to deal with the static charge. Right? So let us take one charge, that is source charge plus Q. This charge, who is creating the field? The charge is creating the field. So source charge creates field. So the source of the field is charge. If it is a static charge, then it is called electric field. If it is a moving charge, then it is called magnetic field. Here it is static charge because we are dealing with the electrostatics. Electrostatics deal with the static charge. So charge creates field. Field will create force. And that force acts on the some other test charge. Small q. What is the force between the source charge and test charge, or how this source charge knows some other charge is present here? That's what given by force between the two charges given by Coulomb's law. F is equal to K capital Q small q by R square, where K is equal to 1 by 4 pi epsilon naught Q small q R square. Fine. So K is equal to 1 by 4 pi epsilon naught, please remember. Fine. So the force between the source and the test charge, right? That is given by Coulomb's law. F is equal to K into Q capital Q source charge, small q test charge. R is the distance between the source and the test charge. How these two charges interact with each other? Because in the world we are full of charges. How these two charges interact with each other? That force is given by this Coulomb's law. What about field? Here we deal with the electric field E. Right? So what is field? Field is nothing but force felt by the charge. So E is equal to force felt by the test charge. Right? So force per charge, that is given by E is equal to by Q. And unit of force Newton coulomb. So the electric field is per coulomb. But we don't use that. What is the main unit we are using is volt per meter. How it has become volt per meter, let me tell you later. So the unit of electric field is volt per meter. In EMF, the units are very, very important. Please remember. Okay. Now from the electric field, we have to take three paths. First path is, let us see here. Where is it? And the first path is okay, fine. Here we go from here, and straight away we go to what you call divergence of electric field. Next path is curl of electric field. Curl of electric field. Third path is gradient of electric field. So I hope understand why I take so much of time for dealing with these three concepts. What is divergence of electric field? Before that, we should know the relationship between another parameter that is called, okay, take some other color. Fine. Here you see there is one more relation. E is electric field. Next one is D. D is equal to epsilon E. This is electric flux density. What is flux? I will explain later when you deal Gauss law. So there is a relationship between E and D. So just a multiplication factor epsilon. So D means E. Both are giving the same name, same meaning. Only thing is it is multiplied by some constant E. So epsilon. So divergence of E is given by del dot D is equal to rho V. Otherwise, del dot E is equal to rho V by epsilon, because D is equal to epsilon E. Epsilon I bring this side. Otherwise, another form is closed integral d dot ds is equal to q when closed. Divergence of electric field. You see, d means divergence of equal to 0. Next, we see curl of electric field. Uh, Curl of electric field is what you call, let me go this way. Curl of electric field is 0. Del cross E is equal to 0. Other term is E dot dl is equal to 0. Both are telling curl of electric field is 0. Why? We know electric field is due to static charge. The charge lies here. We know electric field lines will go like this only. It is spread. It is not rotating. So divergence is 0. So sorry, curl is 0. So curl of electric field is 0. Why E dot dl is 0? Is E dot dl means dl is a line integral. Line rotates. So this is talking about the rotation of electric field. So E dot dl, it is rotating, electric field rotation 0. This is also curl of electric field or rotation of electric field 0. So curl of electric field is 0. Fine. So this is another thing we have to remember. Next, electric field due to some charge configuration we must know. What are those configuration? Let us see. Electric field due to, now we come here, electric field due to point charge. That is given by E is equal to KQ by R squared, right? AR. Because electric field is a vector, force is a vector, so area also we put AR, no problem, right? Okay. Next, electric field due to line charge, E is equal to rho L by 2 pi epsilon naught R AR. Then electric field due to surface charge is E is equal to rho S by 2 epsilon naught AR. Right? So these things you must know. Electric field due to point charge varies as a function of 1 by R square. Electric field line charge varies as a function of 1 by R. 1 by R square, 1 by R. There is no variation. What is the reason? I will tell you. Right? And electric field due to dipole. You must know, but it is not that much important. That is Q. So yes, due to some other slide. See, electric field due to point charge varies as a function of 1 by R square. Electric field due to line charge, this is point, this line as a function of 1 by R. Electric field due to surface, constant. There is no R factor. Electric field due to dipole, 1 by R cube. There is a reason for this, right? So general formula for electric field is E is equal to KQ by R square, where K is 1 by 4 pi epsilon naught, Q by 4 pi epsilon naught R square AR. This is what electric field due to point charge. So here you see when R is the distance between the source and the field. Suppose your charge is located here, you want to find the electric field at this point. The distance between the source and the field is R. So from this equation, when R increases, what happens? Electric field decreases. So that is very, very important. When distance between the source and the field point means where you are measuring the field. When the distance between the source and field point increases, electric field will decrease. When R tends to infinity, electric field tends to 0. So electric field tends to 0 at infinity only. So electric field is present everywhere, but we won't feel because the field value is very, very less. So electric field will be 0 only at R is equal to infinity. Very important point. Right here you see electric field due to point charge varies as a function of 1 by R squared. So point charge means this is one point charge. So I want to find the electric field at point P. This is R. So here the electric field varies as a function of 1 by R squared. Line charge means it is like our tube light. It is like our bulb. You remember like this. If you see tube light, suppose at the same point, both are in the same location, this point, it is line. Here it is varying as a function of 1 by R. Right? Suppose if you are having a surface like this and it is radiating light, top and bottom, like this. This was surface. Dipole means we have positive charge and negative charge. This is 1 by R cube, this is point P. Here you see, when you move away from the bulb, that is some yellow color bulb is there no, in our home. When you move away from the bulb towards some point, we will feel that the light of the light will disappear so fast when you move away. But when you move away from the tube light, like say, here it will go slowly. We can see somewhere if you move far away also, you can see the light. But if you move away from the tube light, within a short distance, you won't see the tube light. So that's what here you see. That's why you see, if you put our bulb in the ceiling, it will spread to the more area, like our sunlight. So it will decay slowly, 1 by R squared. The electric field will decay slowly, 1 by R squared. But here you see, here it will decay fast. Sorry, here it will decay fast, here it will decay slowly. And you see in the surface, we won't see the change. If you see from top, the surface will emit same light. If you see from the bottom, it will emit from the same light. So it is independent of R. The electric field due to dipole decays so fast because at this point, positive field creates some positive charge creates some electric field, negative charge creates some opposite electric field. So the field created by this one will be cancelled by this one. So your electric field decays fast. That's why it is 1 by R cube. Right? So electric field due to bulb decay, that is point charge decay next. Electric field due to line charge decay next. Right? Surface charge, there is no change in electric field if you see from the top or if you see from the bottom. That's what we can see. So this tube light glow will for long distance, this bulb will glow for short distance. If you have two bulbs with opposite colors, the resulting light will be very dim and it won't cover much distance. So it is like this example. Okay. Next, gradient. So whenever you want to deal about the gradient of electric field, we must work with the potential, right? Because gradient is a del operator operating on scalar and results in vector. So E is equal to minus del V. This is gradient. It is potential V that we know, right? So this is very, very important relation. They will ask question from this area, surely. Why this area is very important? We all know that it is very difficult to deal with the electric field because it is a vector. It has both magnitude and direction, so it is very difficult. So instead of dealing with vector, I want one quantity which is working with the scalar. That quantity that should be equivalent to this electric field. So that is what our potential V. So V in terms of E is given by V is equal to minus E dot dl. So these two relations are very important. Surely they will ask question from this area in getting, right? So potential due to point charge is given by V is equal to KQ by R. Fine. And potential due to dipole, only these two are very important. That you can see as QD cos theta divided by 4 pi epsilon naught R square. Potential scalar electric field vector. Fine. So that is very, very important. So it is electric field due to point charge. Sorry, potential due to point charge. It is potential due to dipole. Electric field due to dipole I have given here. You can see it in the book also. So that is one more thing we have to remember. And next point we should know is potential. With that, what is another one point with respect to potential is, let me take this color, del squared V is equal to 0. Hope you have seen this. This is called a Laplacian operator. All right. And this operator is second order del operator with V. Next operator is del squared V is equal to minus rho V by epsilon. This is called Poisson operator. Poisson equation. Right? This is called the Laplacian equation. Right? So electric field, from electric field, divergence of electric field results in these values, and curl of electric field results in these values. You see, we have differential form, integral form. This is differential form. This is integral form. Integral form, you know, it is integral. Differential form means why it is called differential? Because del is dou by dou x, dou by dou y, dou by dou z. So del cross, if you use del, that is differential form. Integration, integral form. So for electric field, divergence, differential form, integral form. Both will give the same meaning. Curl, differential form, integral form. Gradient, this is the only thing. Differential form, integral form. Fine. So these are all the things we must know about electrostatics. This is electrostatics, right? So detailed analysis within a short span I cannot cover. If you want real meaning and examples, please refer my channel. So I shared it with you, sir. You can ask. And another thing we have to remember is boundary conditions. Boundary conditions of electric field, right? So here at conductor surface or conductor free space, the thing we must know is inside a conductor, electric field is 0. This question they will ask in lot of exams, so we must know. Inside a conductor, electric field is 0. When you have a conductor like this, it is a free space. It is a conductor. At this point, boundary, this is the boundary splitting conductor and free space. What is the nature of electric field? So here, the tangential component of electric field is 0. We know a relationship between D and E. D is equal to epsilon E. E0 means D also 0. So tangential component of D is also 0. D is electric flux density. So this question they may ask, right? What is the tangential component of electric field at conductor free space boundary? Then En, normal component. N means normal component of electric field is rho s by epsilon. And epsilon, if I bring this epsilon E here, epsilon E is D. So Dn is equal to rho s. This is very, very important condition. What is this? Where we are using this? Conductor. Conductor is nothing but our wire. Free space means our space. So above the boundary, if you touch your wire, these things you can see. Hereafter, whenever you touch your charger, phone charger, or any wire, you must remember when you touch that at the surface of the conductor, suppose if you have a red wire, that if you touch that red, you feel that electric field, tangential component of electric field is 0, tangential component of electric flux is 0. That means they won't be tangential. They will be normal. Normal is not zero. So electric field normal is given by rho s by epsilon naught. That is normal component of electric flux density is equal to rho s. These four conditions must come to your mind hereafter whenever you touch your charger or any wire, phone charger, laptop wire. These are all the four conditions you will feel, right? Next, dielectric boundary. Dielectric, dielectric boundary. Dielectric boundary means we can see paper and wire, right? So two papers. In between, when you touch a paper, paper is a dielectric material. So when you touch any other, when you make two dielectric to interact, what is the boundary condition? Is tangential component are not equal to zero. So let us assume this is material 1, this is material 2. So ET1 is equal to ET2. Tangential component of electric field in material 1 is equal to tangential component of electric field in material 2. Second condition is dN1. Normal component of material 1 and the normal component of material 2 of electric flux density is equal to rho s. Right? So these boundary conditions are very, very important in electrostatics. Right? So these are all the things that we must remember about electrostatics. So just to see electric field, go for divergence, go for gradient, go for curl, make this equation simple. That's it. So they won't ask beyond this from the exam. The thing you have to remember is the concept behind everything, right? So when you solve a potential problem, I have one problem in gate. So at that time I will explain potential in detail. Now we come to magnetic field or magnetostatics. Okay. Magnetostatics. Right? Fine. Okay. Here we can see that. Okay, as usual, source. Here the source is current element. Right? Why single charge cannot be a source of magnetic field? Why single stationary charge? Why current element is a source? Why stationary charge is not a source? We know magnetic field is created by moving charge. So moving charge means it should have some path to move. If the charge lies here, it should have some path to move from this point to some next point, right? So moving charge only create magnetic field, we know. So when the charge wants to move, it should have some path or length. Path will move in, charge will move in the wire or current element. Current element is nothing but a small wire. So it needs some path to travel. Then only it will move. So stationary charge cannot create magnetic field, and current element only creates magnetic field because moving charge requires path. Moving charge requires path to travel. If there is a path, then only it can move. Otherwise, it cannot move. So magnetostatics is created by moving charge, which is nothing but generally we can call a current element is a source of magnetostatics. So like in a gas, in electrostatics we have gas law and the Coulomb's law. Here we have what you call Biot-Savart law. As per Biot-Savart law, H is equal to magnetic field. H is equal to ideal cross R vector divided by 4 pi R square. Right? This is what Biot-Savart law. Here H is a magnetic field. Ideal is a current element. This is called current element ideal. It is a vector quantity. It has both magnitude and direction. Magnitude is I, direction is dl direction. Ideal is nothing but a current element. R is the distance between the current element and the field point. Distance between source and the field point. So suppose if your current element lies here, this is what ideal. It's not that much big, it is very small. I want to find a magnetic field at this point. So this distance is R. So H is equal to ideal by ideal cross. It is not a multiplication, it is cross product, dl. So ideal cross vector, cross product between two vectors by 4 pi r square. You see, in Coulomb's law also we have studied Q1, Q2 divided by 4 pi epsilon naught r square. So Coulomb's force is also 1 by r squared law. Biot-Savart law is also inverse square law. Inverse square law. Both are called inverse square law. Next, what we have to know is Ampere circuit law, which is like our Gauss law. Ampere circuit law. That is H dot dl is equal to I enclosed. Otherwise, del cross H is equal to J. Now you see curl of magnetic field, right? Curl has come. So here you see in Gauss law we have studied d dot ds is equal to Q enclosed. Here I enclosed. That is the difference. So here it is a closed line, that is nothing but a loop. It is a closed surface, right? So this Gauss law, the equivalent version is Ampere circuit law. This is Biot-Savart law, the equivalent version is Coulomb's law. That we have to know. Next, so here you see curl of magnetic field has come. Next, we talk about divergence of magnetic field. Right? So divergence of magnetic field is given by what is called del dot B. So before that, we must know what is B. B is nothing but magnetic flux density, like our D, electric flux density. B is equal to mu H. We have already know D is equal to epsilon E. This is electric field, electric flux density. Magnetic field, magnetic flux density. So del dot B is equal to 0. This implies del dot H is equal to 0, right? So because B is equal to mu H, H you can take H you substitute mu, bring this side, it will become 0. So what it is telling, divergence of magnetic field is 0. Why divergence of magnetic field is 0? We have studied in our school days itself. We know when you have a magnet, if you draw the line in the 11th or 12th we studied, we have drawn a magnetic field line like this. It has started from north and ended to north, right? So there is no starting point, there is no end point. Because we don't know where it is starting. It is rotation, right? It is not divergence, it is rotation. So magnetic field has curl. It is not spreading. Divergence is 0. That's why you see curl of magnetic field here. Curl of H is del cross H is nothing but curl of H, curl of magnetic field. Curl of H is not equal to 0. Fine. Here you see divergence of magnetic field. No need to prove and all. No need. In electromagnetics we can understand from the mathematics. Magnetic field will not diverge. Divergence of magnetic field is 0. Otherwise, magnetic field will not diverge. Right? That is the point. So what is the equivalent integral form? Del dot V0 means it is B dot ds is equal to 0. Right? So it is the equivalent integral form. It is divergence in the integration form. Here you see in all the equation, in these two equation I put closed integral. Why? If you put open integral, the equation will be wrong. In the exam, you will get 0 mark. Why it is closed? We show that who is the source of magnetic field? Current element. So current will path in the closed loop only, as we know. Closed path only it will flow. So current will not flow in open path. So the integral must be closed. Here also the integral must be closed, right? So don't forget that. They may ask this question, and without open integration, if you solve that, the answer will become wrong. Okay. So it is divergence. Next, what is the only thing we have? Gradient. Gradient we know, like E is equal to minus del V. This is a potential. It is scalar electric potential. V is electric potential. Right here. So electric field is negative of electric potential gradient. Right? Del V is gradient of potential or potential gradient. So electric field is opposite to the potential change, right? That is what the meaning. Now we see what is magnetic field in respect to gradient. Here, okay, let us take this black color. So similarly, magnetic field H is equal to minus del Vm. Vm indicates magnetic potential. Right? So Vm we know it is a magnetic potential. Like our what do you call? We had a Laplace equation in the what electric field, no, del squared V zero. Laplacian for electric field. Similarly, Laplacian for magnetic field is del squared Vm is equal to 0. Laplacian. Similarly, we have Poisson. What is that? Del squared V is equal to minus rho V by epsilon. Laplacian as a Poisson for a magnetic field, del Vm is equal to minus mu naught J. This is Poisson equation. So both are matching. You study like this. All right. Next, I want to emphasize some important point. We know electric field is given by KQ by R square. H, just now only we have studied, H is equal to IDL cross R divided by 4 pi R square. Del cross H is equal to J. Similarly, we studied del dot D is equal to rho V. This I explain later in Maxwell's equation. Fine. So very good. What is the important point we must remember from this is, I will explain. In any mathematical equation, right hand side is a cause and the left hand side is a effect. So you see, this is a cause, this is a effect. So you see, charge creates electric field. Cause. Who is the cause of electric field? Charge. The formula is easy to remember. Here you see, I told the magnetic field is created by current element. Ideal is a current element, I told. This is a cause, this is the effect. Right? This is the effect. You see, this is current density. J is current density. I will explain current density now. Current creates rotating magnetic field. I told electric field will diverge. We remember electric field will spread or converge. This is E. This is E, negative charge. But magnetic field just now only I draw. It is rotate. So what is the meaning? This equation I can say current density creates del cross H is nothing but rotating magnetic field. Magnetic field will always rotate. That's what we have studied from our school days. That is this equation. This equation is nothing but Ampere's circuit law. Here you see this is Gauss law. What it is telling? Rho V charge density. Rho V is volume charge. Volume charge creates delta D, divergence of D. D is nothing but E. del dot E is equal to rho V by epsilon naught. So volume charge creates del dot E, diverging electric field, diverging electric field. This is what diverging electric field, right? This is diverging electric field. This is negative diverging electric field. Who is creating that charge? That's what Gauss law. Right? So these things we must remember. And the other thing we have to remember is there are many similar equations like this. Already I told d dot ds is equal to q n cos. I explained this later. Q n. This is Gauss law in integral form. It is differential form. That is pi. There is one more equation. J dot ds is equal to I. This equation also we will use widely. J is current density. Current density means what is population density? Population per area. Current density means current per area. Or current at that area is very, very small. That is tends to 0 point. So very, very small. 0 means not it is 0, it is very, very small area like that. So current means we find across some lengthy element. Current density means we find at particular point. So when we study antenna, we study about J only, not I. Why we study J in antenna? Because antenna is dealing with space. In space, we can find everything at particular point. So there we use current density. Whereas in wire, we use current. Because in wire, we can find current. Right? So in space, we cannot find current. Because in space, there is no charge. So we can find current density only. Right? So this is the fundamental concept of antenna. So current density means current per area. So what is the unit? The unit of current is A, area is meter square. So the unit of current density is ampere per meter square. So you see like this we have a current, what do you call? J dot ds is equal to I. So how this equation has come, I don't explain, but I give shortcut. You see, J is current density, ampere per meter square. If you multiply ds is area meter square, so that will give ampere. So if you forget the equation, use the unit and find the answer. So current density means what particular point. If you add all the current at every point, it will give total current. That's what current into area. Current density means current by area. Current is equal to current density into area. That's what this one. Right? So d dot ds, j dot ds. These are all the equations we use widely in our EMS. And the next one I want to emphasize is what you call del dot j is equal to minus dou rho v by dou t. This equation is called a continuity equation. This is very, very important equation. Please remember this equation because this is used in the Maxwell's theorem. Right? Okay, how much time? Okay. So delta J. You see what is the meaning? Divergence of current density. Dou rho v by dou t means negative. This negative means decrement. So decrease in charge density with respect to change in time. Dt means change in time, right? So how it has come, this is very, very important. Let us assume here we have one bar sphere, there we have 5 charge or 6 charge, right? So divergence means spreading of current, right? So divergence of current means what do you call, this is spreading of current, okay? Something wrong. Please wait. So here you see that Please wait. I'll go. Where we start? Okay, I'll go there. Right. So I go here. Um, Fine. Okay. Del dot j is equal to minus dou rho v by dou t. This is what we know. Right. So let us take this box which has 5 charges 1, 2, 3, 4, 5. Right. Suppose divergence means divergence of current. This is decrease in charge. See, divergence of current, it is a source. From here, the current flows out means what? Charge flows away. Current is nothing but charge flow. So if current flows out means, let us, each charge represent 1 ampere. If 3 ampere current flows represent means 3 charge went out. Yes or no? So this 3 went out. That is why 3 ampere current flows. If 3 charge went out means how many charges are remaining inside? 3. That means 3 charge has been lost inside the box. That's what the lost in charge. So if the current flows out of the surface, that much charge will be lost inside. So that is same only, right? So it is maintaining the continuity. If 3 goes means that much will be lost here. That's why it is called continuity equation. Fine. So this is a very, very important equation. By using this continuity equation only, Maxwell has proved Ampere's circular law has some drawbacks. Right? Then only he proved electromagnetic wave can be propagated. So this is a very, very important equation called continuity equation. Fine. Okay. Next. So what is this question? This question they have asked in the exam. So let us see this. Here you see, okay. So we have some problem. So let us start with this problem. I told already relating E and V, they will ask one question. The question is if electric field intensity is given by E is equal to x ux. Ux is unit vector, uy uz volt per meter. What is the potential difference between x and y? So they gave E and ask us to find the potential difference between x and y. So if we know E, how to find V? Vxy is given by minus x2y E dot dl. This is what the relation I told already. E we have electric field vector. dl we have to find. It is a Cartesian coordinate system because ux, y, z. So for Cartesian coordinate system, dl is equal to dx ux dy uy plus dz uz. Clear? So E we know, dl we know. If we take dot product between E and dl, x and x, ux ux 1, so it is x dx. Similarly, uy 1, so y dy. Similarly, uz 1, so z ds. Now we got EDL. X and y we know. Now we have to substitute in the formula. So x is 2, 0, 0. Y is 1, 2, 3, I feel, right? Okay. So V is equal to minus x2y E dot dl. E dot dl is dz. Dx plus y dy plus z. Clear? So instead of x and y, I can write as minus I take outside, so y to x. So if I change the limit, the minus will come, so it will become plus y to x, x dx, y dy plus z ds. So I split the integral into t part, x dx, y dy plus z dz. Right? This integration is varying with respect to x. So x, so it goes from y to x. This is why in y x is 1, in x is 2. So 1 to 2. Similarly, in y, dy, y varies from 2, y is 2, here y is 0. So 2 to 0. In y, z is 3, in x, z is equal to 0. So 3 into 0. If you simplify this, what you get is 5 volt. So V is equal to 5 volt. This is the answer. So this type of question surely they will ask. They will give E and ask you to find V, or they may give V, ask you to find E. So if they give E, V, it is E is equal to gradient of V, right? So don't forget. Right. Next question is, you see a point charge of 1 coulomb is placed in a space with permittivity 8.85 into 10 power minus 12 farad per meter as shown in the figure. It is here, 1 nanocoulomb. The potential difference between VPQ. So the potential at this point is VP, the potential at this point is VQ. The potential difference between VPQ between 2 points P and Q, which is at a distance of 40 meter and 20 millimeter respectively. P is at a distance of 40 millimeter from the source. Q is at a distance of 20 millimeter from the source. So they ask what is VPQ, right? VPQ means it is VP minus VQ. The general formula for V is, I told, it is KQ by R, that is 1 by 4 pi epsilon naught into Q by R. Right? So VP means potential at point P. So it is 1 by 4 pi epsilon naught Q. It is source charge 1 nanocoulomb. So 1 into 10 power minus 9. Fine? Okay. 1 nanocoulomb. Clear? Next. Minus VQ. VQ is again 1 by 4 pi epsilon naught into same R. R is there. This is P is at a distance of 40 millimeter. R is the distance between source and P. So R is 40 millimeter for here. So 40 into 10 power minus 3. This one is, let us assume this is R1. So I put as R1. R1. Here R2. R2 is 20 millimeter. So 20 into 10 power minus 3. So R1 is 40 into 10 power minus 3. It is 20 into 10 power minus 3. Again, source is 10 power minus 9, 1 nanocoulomb. Fine. So, if you simplify, what you get is 1 by 4 pi epsilon naught value, you must remember, it is 9 into 10 power 9. So, like that you have to solve. So, it is 10 power minus 9 divided by 40 into 10 power minus 3. Minus, here also 1 by 4 by epsilon naught is 9 into 10 power 9 divided by 20 into 10 power minus 3. If you simplify, what you get is 225 volt, right? So minus 225, because you see it is 1 by 40, it is 1 by 20, so this must be a small number, it must be a big number, so the answer will be in negative, minus 225 volt. Right? This type of question you can expect in between E and V are potential, right? Okay. And another point we have to remember is electric field and electric potential are always perpendicular to each other. Perpendicular means it is orthogonal, right? So electric field and the potential are perpendicular to each other, so they will cut each other orthogonally. So don't forget this point. You see, this is a wonderful question. Which of the following statement holds for the divergence of electric and magnetic field? Magnetic flux density. What is electric flux density? Electric flux density is D. Magnetic flux density is B. Divergence of electric flux density, delta D, I told already it is rho V, Gauss law. What is the Divergence of magnetic flux density, we know magnetic flux will not diverge, so del dot B is equal to 0. So for magnetic flux density, divergence is 0. So option D is the right answer. Both are 0? No. Divergence of electric field is not 0. So it is 0 for electric flux? Never. It is 0 for electric? No. Right? So the answer is it is 0 for divergence is 0 for magnetic flux density only. Like this only they will ask question, right? So you must know the concept, then only you can answer the question. Here you see, this is one more important point I forgot to mention. Electrostatic force is said to be conservative. We know already the electric field will diverge. If del cross E is equal to 0, then E is called conservative. Right? So it is a big concept. Just you must remember this point. If divergence of the vector whose curl becomes cross product becomes 0 will become conservative. So the electrostatic field is said to be conservative when curl of the field is equal to 0. So E is said to be conservative only when del cross E becomes 0. So don't forget, this is very important. This is called conservative field. Conservative field is a field whose curl del cross becomes 0. Right? That's the point. Another one point, vector potential. We know vector potential is a vector whose curl is equal to magnetic flux density. Vector potential only they asked, so we know E is equal to minus del V, right? Whose curl of the vector potential. So this vector potential, it is talking about magnetic field. So del cross V. Okay. So vector magnetic potential, I didn't mention this point. So vector magnetic potential is represented as A is equal to, sorry, B is equal to del cross A. Please remember this point. This A is what you call vector magnetic potential. B is magnetic flux density. So vector magnetic potential is A. So B is magnetic flux density, that is equal to del cross A. So let us see, vector magnetic potential is a vector whose curl is equal to magnetic flux density. You see, it is curl of, del cross means curl of vector potential. You see, the first answer is correct. Vector magnetic potential is a vector whose curl is equal to magnetic flux density. Yes, curl of vector magnetic potential is magnetic flux density. So option A is a right answer. Whose curl is equal to electric field intensity? No, it is not E. So this is wrong. Whose divergence? We have only curl. This is wrong. Which is equal to product of E and H? That is also wrong. So option A is a right answer. Please remember this formula I forgot to mention. Vm is scalar magnetic potential. That's what I have mentioned already. A is vector magnetic potential. Right? Okay. So now we come to the Maxwell's equation, right? So before coming to Maxwell's equation, I give some shortcut or a point to remember. You take charge, right? Study of static charge, electric field. Study of moving charge, magnetic field, right? Force per charge. Sorry, this is electrostatics. Magnetostatics. Force per charge, electric field. Work done per charge, magnetic field. Movement of charge, current, accumulation of charge voltage. Next, we have to know orientation of charge polarization, right? Uh, charge per length, line charge density, charge per area, surface charge density, charge per volume charge density, right? So these are all the things we must remember. And in electromagnetics, we have to remember the notation also. We have A to Z. Let us see what is A. I write with a different color. A is, just now only I told, vector magnetic potential. B, magnetic flux density. C, capacitance. D, electric flux density. E, electric field. F, force. G, conductance. Fine. H, magnetic field. I have no space, I write here. I, current. J, current density. Right. K, 1 by 4 pi epsilon naught, that is equal to 9 into 10 power 9. L, inductance, that is self. So if there is any space, okay. M, mutual inductance. N, number of turns. Hope you should have studied in inductor. There is no O. P, polarization. Q, charge. R, resistance will come. S, power flow, that we will deal in the next class. Right? T, Tesla. U, potential energy. V, potential. W, work done. X, Y, Z coordinates. These notations we are using widely, right? So these things we must know. Potential is work done per charge, right? So I didn't write. Okay, potential as, oh, work done per charge is potential, that is V. Moment of charge is current. Okay, so those things we must remember. Now we go to Maxwell's equation. So this is very important equation. So first I write the equation. It has two forms. One is differential form and another one is integral form. Right? Gauss law is different. First law, first Maxwell's equation. Gauss law, just now I told, delta D is equal to rho B. So Gauss law is first Maxwell's equation. The equivalent form is, we know, d dot ds is equal to q enclosed. This is Gauss law for electric field. Second one is Gauss law for magnetic field. That is nothing but, we know, del dot B is equal to 0. Magnetic field will not diverge. Similarly, B dot ds is equal to 0. Again, it will not diverge. Dot, right? Okay. Then Faraday's law. Faraday's law is del cross E is equal to minus dou B by dou T. Here E dot dl is equal to minus dou B by dou T dot ds. Right? This is Faraday's law. Then modified Ampere circuital law, that is given by del cross H is equal to sigma E plus epsilon dou E by dou T. Here H dot dl is equal to closed integral, AC sigma E plus epsilon dou E by dou T dot ds. These 8 equations are called Maxwell's equations. See, both are telling the same meaning I told already. Right? This is Gauss law, this is the Gauss law for electric field, Gauss law for magnetic field, Faraday's law, and Ampere's circuital law modified. So I will explain everything now. So first we will see, what's the time? Gauss law. So Gauss law is telling that psi is equal to d dot ds. So flux, electric flux passing through any closed surface is equal to charge enclosed by the surface. So that's what the statement, closed integral d dot ds equal to q. So it is q enclosed. Whenever you write, just write the word q enclosed, otherwise Gauss law will be invalid. Here you see d is equal to epsilon e, we know. Right? So what Gauss is telling, the electric, I told right hand side is Gauss, left hand side is effect. So from this equation, d is equal to epsilon e, so e dot ds, that is equal to q enclosed. You see the enclosed charge creates electric field. So that's what, that enclosed charge is equal to flux. That's what Gauss law states. So it relates charge distribution and the resulting electric field. This is charge, this is electric field. So the enclosed charge will create the resulting electric field. That's what Gauss law. Charge creates electric field. That's what I told in electrostatics. So charge is a source of electric field. That is proved by Gauss law. That's what this equation. Right? That is what this is integral form. Fine. And this is differential form because you see del dot. Del came, so it is differential form. So that both are telling the same thing. Del dot d. So this I can write as del dot d is equal to rho v because epsilon, if I bring epsilon e is equal to d. So charge creates electric field. Diverging electric field. I explained this already. So divergence of electric field gives the density of the source, right? So that's what we have to understand. Right, so Gaussian surface and all we don't need. Next, we see Gauss law for magnetic field we have studied already, right? Magnetic field will not diverge. That's what d dot ds equal to 0. There is no magnetic monopole, right? In electric field we have plus separately, minus separately, right? But in magnetic field, you see if you take this magnet, if you split it, again it will split like this, ns, ns. Right? There won't be no n, there won't be no s. That's what, there is no magnetic monopole. It is a monopole. Only one polarity, positive or negative. It is always dipole, north and south. So there is no magnetic monopole in the charges also. Magnetic charges will always be dipole only. That is very important. When there is a dipole, it is always closed. Yes or no? Here one plus, here one minus means plus will go to minus because the electric field start from plus, end at minus. So since divergence is 0, always there is no magnetic monopole. Very important. Right? So here you see they asked one beautiful question in Gauss law. Okay, this is easy. I will give some other question. This is a wonderful question. Since I have no time, I run fast. Here you see 30 nanocoulomb, 20 nanocoulomb, and 10 nanocoulomb are located at these 3 points. What is the total flux leaving a cube of side 6 meter? So flux leaving means it is a Gauss law. So cube of side is 6 meter. First we draw that. Right. So this is cube. Right. This is cube of side 6 meter. Right. So this is center. 6 meter means from here to here 3 meter. From left hand side 3 meter. So let us assume this is X, this is Y, this is Z. Right? So this is positive Y, this is negative Y. Similarly, it is negative Z. This is 3, minus 3, like that. It is minus 3, this is minus 3, this is plus 3, this is minus 3. See, first thing, charge 30 nanocoulomb located at minus 1, 0, 2. So minus 1 means it is X is equal to minus 1, maybe somewhat here, 1, Y0, Z2. So it may be somewhere here inside the box. So here 30 nanocoulomb. Next you see 0, 0, 0 at the origin minus 20 nanocoulomb. 0, 0 here minus 20 nanocoulomb. Next one at 1, 5 minus 1, 10 nanocoulomb. 1, 5. X is equal to 1. Y5 means it will go outside the cube because the length is 3. Y5 means maybe here. 1, 5, 1 means maybe somewhere here outside. So here 10 nanocoulomb. What is the total flux leaving? So as per the Gauss law, what is the question? The flux leaving is equal to, you see the flux leaving is equal to charge enclosed. Here you see flux leaving is equal to charge enclosed. In the cube, what are the charges enclosed? Only minus 20 nanocoulomb plus 30 nanocoulomb. So what is the total charge? 30 minus 20, 10 nanocoulomb. This won't be considered for the calculation because flux leaving from the surface is equal to charge enclosed. Only these two are enclosed. So the result is 10 nanocoulomb. So the answer is 10 nanocoulomb. Now we come to this problem. Here you see Q is equal to 10 microcoulomb and 20 millicoulomb are placed at 1, 1, 0. So Z is 0. Here also Z is 0. So it is XY plane only. So let me write like this. X, Y, otherwise as usual we write okay XY. So when X1, Y1 we have 10 microcoulomb. X1, Y1 10 microcoulomb. When X minus 1, Y minus 1, 20 microcoulomb. So this is X minus 1, Y minus 1. Here 20 microcoulomb. What they ask is what is the total flux leaving through a plane? Z is equal to 20. Z is equal to 20 means this is XY plane. So this is X, this is Y. Z plane will be coming out of the screen or going inside the screen. So I can draw like this one. This may be coming out or going in. So the flux here may go here or whatever be the charge, the flux from this charge will go inside the screen or come out of the screen. So total, similarly, it is plus 20 means bottom side will be, suppose if flux is coming out means let us assume plus 20. If the flux is going inside the screen, let me assume it is minus 20. Right? So what will be the total flux? It is the average of these two. So 20 plus 10 divided by 2, it is 15 microcoulomb. Right? So answer is 15. Right? Whenever they ask the question like this, you just put if two charges are in one plane and they ask what is the flux going through the third plane, just take the average of the charges. If 2 divided by 2, if 3 divided by 3. Okay. You see the next question is time. Okay. The electric field strength at distant point P due to a point charge located at origin is 100 volt per meter. So this is the point charge, this is the origin, right? This is the point P. Here the charge is located. At this point, electric field is 100 volt per meter. If the point charge is now enclosed by a perfectly conducting metal sheet sphere, it is closed by the sheet sphere like this, whose center is at the same origin, like this only. Then electric field strength at the point P outside the sphere, right? So initially we have charge at this point, electric field 100 volt per meter. If the metal sheet is kept enclosing this charge, what is the electric field at this point? That is the question. So we have studied in 12th standard, if there is a positive charge inside some metal sheet, it will induce some negative charge in the metal, that we studied in 12th standard itself. So if there is a 5Q means it will induce 5 minus Q here. 100Q, it will induce minus 100Q. So what is the total flux leaving? Total flux leaving is here on the surface we have minus Q, inside we have plus Q. So what is the total flux? 0. If flux is 0, field is 0. Yes, what is the reason? Flux is nothing but field lines passing through a surface. Field lines passing through surface. So from here we understood total flux is 0 because charge enclosed is 0 as per the Gauss law, because psi is equal to Q enclosed, right? So net charge is 0. So this implies pi 0. Okay. So flux 0 means electric field is also 0. So answer is option A. Right? Okay. This question also get question. You can try in your home based on the Gauss law. If you have any doubt, please ask me in my contact number. Okay. Next one is Faraday's law. So we don't have time, directly write Faraday's law. This is what Faraday's law, right? So this one, Faraday's law. See, the first thing you have to remember about Faraday's law is Faraday is the first person who bring the term time. Whatever we studied so far, we never used the word time or parameter time. So Faraday brought the term time. So time varying field, the electric field varying with respect to time or magnetic field varying with respect to time, that concept was introduced by Faraday. Here you see time varying field because B is magnetic field that is changing with respect to time. That is time varying field. So you see already we studied E dot dl is equal to 0 or del cross E is equal to 0. Right? Here you see, here Faraday says that del cross E is equal to minus dou B by dou T. Del cross E means curl. Here also you see rotation. So this rotation, without this rotation, both the equation will give different meaning. I told differential form and integral form have the same meaning. So del cross means the integration should also talk about rotation. That rotation is given by this curve, this closed integral. So from this I will explain. You see right hand side is cos. You see the magnetic field which varies with respect to time creates rotating electric field. So that's what Faraday's great contribution. Change in magnetic field creates change in electric field. That's what Faraday introduced. Right? So Faraday's main contribution is, here you see, right here, del cross E is equal to minus dou B by dou T. This implies change in B is nothing but mu H, so magnetic field. Change in magnetic field creates change in electric field. You may ask, where is a change? Del is nothing but dou by dou X, change, right? So change in magnetic field. Magnetic field varies with respect to time. If the time varying magnetic field creates spatially varying, X is nothing but changing with respect to space. Time varying magnetic field will create spatially varying electric field. That's why this is very important. Right? So that's what we must know. Next question. So this I will be later. Next, fourth equation is modify modified Ampere circuital law. This is what Maxwell's fourth equation. Modified Ampere circuital law. What is Ampere circuital law? Del cross H is equal to J, where J is equal to sigma E. We must remember, right? This we have studied in electron devices itself. This is Ampere circuital law. Modified Ampere circuital law. Maxwell has found some problem in this equation and clarified it. That's what a modified Ampere circuital law, that is given by JC plus JD vector. JC is sigma E, JD is nothing but dou D by dou T. Here JC is conduction current density, J current density I told, C means conduction. JD is displacement current density. We know D is epsilon E, so epsilon is constant, I take it outside, dou E by dou T, del cross H. Here you see there is a difference between Faraday's law and Ampere's circuital law. Faraday told change in magnetic field will create change in electric field. Cause effect. Change in magnetic field, change in electric field. Maxwell told change in electric field will create change in magnetic field. Time varying electric field will create change in magnetic field. So you combine both the equation. As per Faraday's law, change in electric field will create change in magnetic field. As per Maxwell's theorem or modified Ampere's law, change in magnetic field will create change in electric field. E create H, H create E. This is what EM wave. This is the biggest thing, right? So electric field, when electric field changes, it will create magnetic field. That's what Maxwell's theorem, right? When magnetic field changes, it will create electric field. That's what Faraday's theorem. So electromagnetic wave, right? So that's why the wave is able to propagate from one point to another point due to its equal change, right? And the next thing you have to importantly know is, so here you see what is the difference between Ampere circuital law and modified Ampere circuital law? This JD, right? So JD is the biggest contribution of Maxwell. What Maxwell has done? Maxwell's biggest contribution is displacement current density. Don't forget this word. In every competitive exam, they ask this question. Displacement current density. This is the biggest contribution of Maxwell to our communication engineering. JD, that is equal to dou D by dou T. They may ask question from this. They will give D value and ask us to find JD. Just we have to differentiate. So displacement current density is the biggest contribution. In Ampere circuital law, he has used this. Then only this concept has come. Change in electric field will create change in magnetic field. So don't forget difference between the Faraday's law and Maxwell's theorem, right? So those things I have explained here. So that's what we have seen, right? Change in magnetic field results in change in electric field, Faraday's law. Change in electric field results in change in magnetic field, Ampere circuital law, otherwise Ampere modified Ampere circuital law or Ampere Maxwell's law. So that's what happening in our antenna. So when we deal antenna, we have to start from Maxwell's equation only. Then only it will start radiating. Okay. Right. So we know del dot E is equal to rho V by epsilon in free space. What is free space? Free space is a space where there is no charge. Q0. If there is no charge, charge density 0. There is no charge, there is no current. I0. So rho V0 means del dot E0. That's what this equation. Del dot B, no problem, already 0. Del cross E minus dou B by dou T. Del cross B or del cross H is equal to, I told, sigma E plus epsilon dou E by dou T. Right? In free space, sigma is also 0. This is GC. This will be out only epsilon dou E by dou T. Right? So that's what Maxwell's equation in free space. In free space, what is free space? A space without charge and current. That is called a free space. Okay. Why we have two different forms in Maxwell's equation? Think over it and tell me the answer in the groups. Okay. So now we test it. Maxwell's equation gives the relationship between different source. No. Just now only I told it gives the relation between two field, electric field and magnetic field. Next, del dot B 0. It indicates magnetic field is 0. No, there is no existence of magnetic monopole. Right? So that is the correct answer. In free space, just now only I told charge is 0, current is also 0. So our answer is option 3. Okay, next. A field can exist if it satisfies Coulomb's law, no. Gauss law, no. Maxwell's law, no. It has to satisfy all the four Maxwell's equations. Gauss law and Faraday's law are part of the Maxwell's equation. But remaining two we have to include Ampere circuit law and Gauss law for magnetic field. Then only a field will exist. So answer is Maxwell's equation. Next, if the magnetic field is stationary, what is the electric field? Okay, now we have to relate magnetic field and electric field. We know del cross E is equal to minus dou B by dou T. This is relating magnetic field and electric field. If magnetic field is stationary means constant. If B is constant, differentiation of constant is 0. So electric field is simple. Right? Next, displacement current is due to, oh, I forgot to mention it. We know, I told JC conduction current, displacement current. Displacement current is due to, conduction current is due to charge Q. Displacement current is due to field, electric field. Just what I told, no, JD is equal to dou D by dou T. That is epsilon dou E by dou T. So who is the source? E is a source, result is JD. So electric field is a source of displacement current. So field is the answer. Okay, just now only we have seen A dot DL. This is gauge question. Who is relating line and surface integral? This is Stokes theorem del cross A dot ds. Right? It should not be closed C. It is open C only. Right? Okay. Next, you see the Maxwell's equation del cross H J plus dou D by dou T is based on Ampere circuit law. So it is ACL. Next, del cross H as a unit of, this is a very critical question. You see del cross H is equal to, just now only I told del cross H is equal to J. What is J? Current density, ampere per meter square. So this is the answer. Otherwise, we know what is the unit of del 1 by m. What is the unit of H? Ampere per meter. So ampere per meter square. That is also right answer. Next, del cross P dot ds. It is like this only, it should be there. Where P is a vector is equal to, we know what is, again it is like that, del cross E dot ds is equal to A dot dl closed to Ampere circuit law. So P dot dl closed, so option A is the right answer. It is just, so Stokes theorem. Stokes theorem. Fine. Okay. Now, by using the same thing they are asking, so the answer is, you see, this is what a modified Ampere circuit law, H dot dl is equal to J plus dou D by dou T dou S, right? That is the relation they are asking. Now, this is a wonderful question. What is the thing? We know del dot B is equal to 0. First, we have to understand that. Divergence of magnetic field is 0. So, this is wrong answer. This is wrong answer. And we know when static electric field, right? For static electric field, we know del cross E, right? 0. Because electric field will diverge. Electric field will not rotate. So for static electric field, del cross E is 0. And we know del dot B is also 0. So option B is the right answer. Del dot E is not 0 because del dot D is equal to rho V. D is equal to epsilon E. So del dot E is equal to rho V by epsilon. This is wrong answer. Next, you see which of the following are Maxwell's equation? Del cross E is equal to minus OV. So this is Faraday's law that we know. Del cross H is equal to J plus dou D by dou T, Ampere's circuital law, right? 1 and 2. Del cross B is equal to 0. No, it is not at all answer. Del dot B is equal to 0 is okay. So the answer is 1 and 2. So this is the correct answer. Right? Don't think that it is the right answer. This is the wrong answer. Current flow in dielectric. It is due to displacement current. Conduction current JC is due to in conductor only. That's why it is called the conductor. JD will be in free space or dielectric. So current flow in dielectric is displacement current. The following law relates force experienced by two loops of wire carrying current. Coulomb's law, it is indicating force. Newton's law, gravity. This is wrong. Gauss law, what is called? It is charge. Current means H dot dl. So del cross H is equal to J. H dot dl is equal to I. So only Ampere's law deals with current. So answer is this one. Which of the following equation indicate the free magnetic charges don't exist? We know already. There is no magnetic monopole. Del dot B 0. B is equal to mu H. So del dot mu H is equal to 0. Mu we take it outside. Del dot H is equal to 0. This is the answer. Free magnetic means no magnetic monopole. Right? And next one, which of the following is appropriate? Relate del cross H is equal to J, Ampere's circuital law. So this is A. E dot dl is equal to minus dou V by dou T, Faraday law. B. Del dot J is equal to minus dou V by dou T, continuity equation. C. Fine. So like that, everything is based on that. So we will finish it. And remaining thing you solve it. It is very easy only. I will share. Right? Okay. Next wave equation. We must know this relation. Very important. These relations play crucial role. Right? So please remember this. What is homogeneous? These are all just theory only. You can understand. I will explain this. This is the wave equation for perfect dielectric or free space. We have known this. Del square E is equal to mu epsilon dou square E by dou T square. Del square H is equal to mu epsilon dou square E by dou H. Here you see, first you must understand what is wave. Wave is the information carrier. And it is a function of time and space. Hope you have studied in signals and system. We have studied x of t. That is a signal. X is a function of time. So it must be a something which is a function of time and space is called wave. Why these equations are called wave equation? Because you see, this equation is a function of electric field is a function of time. Dou by dou is dou by dou x, function of space. So this equation is function of both time and space. That's why these two equations are called wave equations. Del square E is equal to mu epsilon dou square E by dou T square. This is for wave equation for electric field in dielectric or free space. Wave equation for magnetic field, same thing, del square H is equal to mu epsilon dou square H by dou T square. Fine? Okay. Fine. So what is the problem? You see del square E is equal to mu epsilon dou square E by dou T square. Del square H is equal to mu epsilon dou square H by dou T square. These are all the two equations, wave equations. Fine. So here you see, we know electric field can be written as EX plus EY plus EZ. So it has three components, right? Del is nothing but dou by dou x, AX, dou by dou y, AY, dou by dou z, AZ. You see, when you substitute here, dou EX by dou x first. Similarly, dou Ex by dou Y, dou Ex by dou Z. Similarly, for Y, we have three equations. For X, we have three equations. For Y, we have three equations. For Z, we have three equations. So this is totally 9 equations, right? So for us, it is appearing like a one equation, but inside this, we have 9 different equations. It is very difficult to solve 9 equations. So what we take in normal standard is, we assume electric field is propagating in x direction and it has only Ex component, right? So E has only, it has only Y component. So electric field propagating in X direction and it has only Y component. This is the assumption generally we make. Fine. So what will happen? Let us take this. This is X, this is Y, this is Z. I told, as per the assumption, electric field is assumed to be the propagating in X direction and it has only Y component. Y component means it has this component only. The wave is assumed to be propagating in X direction. So it is EY. Electric field has Y component only. Right? If wave is propagating in X direction and electric field is in Y direction, we have already know electric field and magnetic field will be perpendicular to each other. So magnetic field will be in Z direction only. Like that. Right? So you see, if you see this figure, uh, if you see this figure, it appears that the wave is propagating in X direction. Electric field, I assume electric field has only Y component. If electric field has Y component, wave is in X direction, magnetic field should be in Z direction only. So here you see, in this direction, this plane is, when wave propagates, it appears that this plane is propagating like this. Here it will be like this. When you draw here, it will be like this. So this plane is traveling in this direction. Like that it appears. That's why it is called uniform plane wave. Why it is called plane wave? It is called uniform plane wave. So because 9 equation we cannot solve, to convert into single equation, what we are doing, I assume electric field has only Y component and it is propagating in, you see here, electric field has only Y component, dou squared E by dou T squared, mu epsilon, left hand side, del, electric field has only Y component and it is propagating in only, what do you call, X direction, right? So dou X square. So you see, that's what the equation I converted. Here you see this is an equation inside, right? I convert into only single equation. Here you see it is vector equation, E vector. Here it is a scalar equation. It is nothing but a second order partial differential equation. That's why we are studying partial differential equation in second semester to solve these type of problems. So you see, this is, so the numerator gives what is the component of electric field. So it is Y component. Denominator gives in which direction wave propagates. So this is the, so this question they have asked in GATE exam. I will show that. So this is very, very important. So that's why it is called uniform. Why it is called uniform? So here the magnetic field and the electric field are traveling in equiphase surface. The phase is same for electric field and magnetic field in the space. That's why it is called uniform. That is, amplitude is also constant at every point. Amplitude will not vary for electric field and magnetic field. That's why it is called uniform plane wave. You understand why it is called plane? It appears like the plane is traveling. That's why it is called uniform plane. So this is very, very important with respect to gate aspect. Okay, so everything I told, plane wave, uniform plane wave. Now you see, this is a question. In uniform plane wave traveling in y direction, if wave travels in y direction, at that direction, electric field should be 0 and the magnetic field should be 0, because we know in EM wave, electric field is perpendicular to magnetic field, which is perpendicular to direction of propagation. Since wave propagates in y direction, at that direction, electric field should be 0, magnetic field should be 0. So option C is the right answer. You see, this is a gate question. That's why I have emphasized that if a plane electromagnetic wave satisfies this equation, in which direction it propagates, you see it has x component. Numerator is talking about component. Denominator is talking about direction of propagation. So the answer is z direction. Option B. You see, if magnitude of H is 1 ampere per meter, what is E? So the relation between E and H is E by H is equal to 377. So E is equal to 377 into H, that is 377. H is equal to 1. So the answer is 376.8 volt per meter. You see, identify which of the following equation will not satisfy. So this is one question I have to know. So what we did is, we converted a wave equation into a different scalar equation, right? Dou x squared mu epsilon dou ey by dou t, right? So dou square e by dou t squared. Now you see, if I solve this equation by using second order partial differential equation format, what I get is f of x minus v naught t plus f of x plus v naught t. This is the solution of this equation. Solution will be in this form. What is x minus v naught t? Wave goes from source. This is wave reflected from some obstacle. So x minus means this and all we will use in the next class. So please remember, x minus means wave goes from the source. X plus means wave reflected from some obstacle. So this is what the solution of this wave equation. Okay. Now in free space there is no obstacle. So in free space the solution is only in the form of x minus v naught t. So that's why we are writing sine omega t, no, in the signals and system, sine omega t plus theta, those and all. That's why this is the reason. Because of this solution only we are writing like this in signals and system. So if x minus v naught, the solution, if the equation in this format, then only it is called wave equation. Now you see, identify which of the following will not be a wave equation. You see option C, this is not at all in this format. So this is wrong. So this is the correct answer. So remaining thing and all will be a wave equation. Why? See, they ask not. So this is a wrong answer. How this is you see cos omega t minus beta z format. Hope you all remember. Like this, f of x minus v naught t. So this is in this format. So it is a wave equation. Here also you see some omega t or vt plus some xyz. So it is also a wave equation. You can ask how this is sin a cos b. Sin a cos b means it is sin a plus b plus sin a minus b divided by 2. It is x plus some t format. So this is also wave equation. So a, b, d are all wave equation. Only C will not satisfy the option. So the answer is option C. Right? So that's all about class. I hope I covered everything, but I think I ran fast since we have less amount of time. I want to tell most of the things. So I hope I covered everything. If you are having any doubt, you can ask me in a comment section in my channel. This is my channel, Majid Lectures. You put, you can get it. These are all my WhatsApp number and mobile number. You can ask any doubt regarding GATE exam. So once again, thanks for the opportunity given by the Francis Xavier management and especially Suresh sir. He has coordinated very well and helped me whenever I asked him with so many doubts. So thank you all, my dear students. Thank you.
Thank you, Professor Sheikh Majid sir, for your valuable contribution on GATE syllabus. On behalf of Francis Xavier Engineering College, we thank you, Professor. Thank you. Thank you, sir. Thank you, students.
Thank you, sir.
Thank you, everyone. Thank you, students. You can leave the session now.